So for a variety of different aeromagnetic data sets, I've generated the grids using minimum curvature and then generated grids using trend, reinforced minimum curvature. I've saved them out to individual files, and then I've just created a rendering algorithm which renders those two grids in a different layer. And so we can do some swapping of layers to compare the differences between these grids. So for example, we have here, this is the minimum curvature. So this is a data set called Alkedra, and it's only a small data set, but it's used as an example of something that is quite difficult to successfully grid. So there's with minimum curvature, there's with trend enhanced. Now in all these examples, my trend enhancement hasn't been tuned in any way. I've simply used the default, and it may not be the best settings, but for the time being, I'm just using the default settings. And so you can see that these anomalies here, for example, have become nice and straight. This curve feature has become, there's our trend enhanced, there's normal, there's trend enhanced, normal, trend enhanced. These features along here, less boudinaging. And I think, overall you can say that this has had a pretty beneficial effect on this particular data set. Up here you can see along this feature quite a significant improvement in the linearity of that feature, these features. Up here. I think the thing about this particular technique is that, okay, with minimum curvature, there's an infinite number of solutions, and they'll all match the data just as well. What we're doing here is we're just choosing a different solution. It's going to match the input data just as well, but it's going to, be a different solution, but it's still minimum curvature. Okay, so that was Alkedra. Let's just keep going and see what else we have. So this is one called P574. Turn on flipping. So let's have a look over maybe at these anomalies over here. So with minimum curvature, they're a bit ratty, and you can see, maybe we zoom in, you can see quite significant improvement in the linearity of those features when we go to trend enhanced. Over here perhaps, quite significant improvement. These features come out nice and strongly when it's trend enhanced or trend reinforced. This circular feature becomes more circular, in fact. There's normal, there's reinforced. Let's keep going. P610. These are all aeromagnetic surveys in Australia, just randomly chosen. So here's minimum curvature, here's trend enhanced. Minimum curvature, trend enhanced. You can see there's a significant improvement in that feature. Same deal over here. Quite a significant improvement. And over here, this is really cleaned up nicely as well. Much nicer looking. And a lot of the time, that's the whole point. It's nicer looking. Whether it's better or not might be a bit subjective. So here we have normal. This is a larger data set. There's our trend enhanced. So minimum curvature, trend enhanced. So this feature here, for example, has been nicely differentiated as two linear features. Through here, a bit hard to say. There's normal, there's trend enhanced, some improvement, and then in other areas you might not like it so much. One of these data sets where you could probably fiddle with the settings to see if you can get an improved result. 10900. This is quite a difficult data set. Reasonably large data set. So let's go to normal. So there's our normal. Let's have a look at these dikes out here. This is just with minimum curvature. And you can see that in this case, trend enhancement hasn't really done as good a job as you would hope. I think, let me just check. 1090 east-west survey lines. So probably some fiddling with the parameters needed there to improve that result. Looks a bit better out here. Seems to have done a better job. Let's go on. 1106, 1134. Well, here's 1134, the one that we were looking at before. This was our original data set. Turn on our swapping. So we've got our so here we have our strong boudinage effect, and now we've almost managed to join across those lines into a more coherent linear feature, but not quite. It struggled to get 100% of the way to joining this into a nice feature. Elsewhere it's done a better job. Let's have a look in these very high amplitude areas. So where you've got a lot of signal, there are changes, but it's not as spectacular, not as significant. So 1178. So here's our minimum curvature grid. Here's our trend enhanced. Minimum curvature, trend enhanced. So this one's, this one's done quite nicely. It's really taken out all of this, a lot of this boudinaging, and made quite nice linear features out of it. For example, here, there's a feature through here, which turns into nice traceable anomalies. Out here, they're just pearls on a string, and now they're traceable linear anomalies. So it's done quite a good job out there. Um, 1225. Another difficult data set, quite different. We have trends sub-parallel to flight lines. Sorry, I've got my swapping on. So there's minimum curvature, and there's the trend enhanced. Not a huge difference, but some difference. What else have we got in this one? There's minimum curvature and trend enhanced. So you can see that this one tightens up a fair bit. Though there are some other effects in that that data set which are less desired. Again, it's a case of tuning things. Whoops. Sorry, I'm looking at the wrong one there. Right, so here's Western Australia. Here's minimum curvature. In this case, we're looking at a very high resolution survey. And there's almost no difference between the trend enhanced and the minimum curvature because it's quite well constrained most of the survey, but you can see some differences. So here's normal, here's trend enhanced. Hasn't had a huge effect in that particular survey. And then there are a bunch of surveys like that are very much the same. Let's just take a look at, say, one more. This is 1261. Again, the differences are quite subtle between the minimum curvature and then trend enhanced. So if you see some changes in here, for example, but the default settings haven't had a really significant effect on this data set because it's pretty well constrained, very tight line spacing. Some improvement along that feature. So that is the trend reinforced minimum curvature gridding as well as minimum curvature gridding using the virtual gridding engine in ProRaster Scientific. You can go to the Microsoft Store and get a 7-day free trial of ProRaster Scientific, so you can give it a go. Use the multi-banded point import routine to create your MRP files. You have to have an MRP file to contain your points, and then you can do your gridding. To get your grid from something that's virtual and on screen to something that you can ship to another person, you use your export raster option. You just export your virtual raster out to a real raster like a GeoTIFF or something, and that can that will work on grids of any scale, at any resolution, and you can produce your final products that way. So give it a try and let me know how it goes by sending an email to my website, and thanks for watching.